Hi everyone, I'm going to be working on the Honors Algebra 2 Unit 1, Topic 1 through 3, SLT 1 through 18. I'm going to be going through this, there's about 6 pages, so I'm guessing I'll probably end up doing about 2 pages per video, so please make sure that you take a look um, at some of the links below to kind of help you along with just kind of following along with the videos. I'll be posting them uh, pretty much one after the other, so we'll kind of just get started. So when we're working with these types of problems, it's a good idea to understand the parent function. So the parent function to, let's say, the square root, so square root of x, it looks something like this. So we know we have a vertical stretch of 2. It's a reflection over the x-axis. It's moving right 3 units and moving up 5 units. So what I like to do is I like to think about some types of values, x and y, so that I can see right here that says x minus 3. So I'm going to most likely choose a value that is 3 there. So that will give me 0, 0 times negative 2, which is also going to be 0, and then 5. You can also use your calculator for this, so you can kind of just get values for your table too. And I'm going to choose actually also 4. So what that will do is they'll give me square root of 4 minus 3, which will give me 1. Square root of 1 is 1, negative 2, and then plus 5. So we're really doing, in a sense, negative 2 plus 5, which is going to give me 3. And really, that's it. That's all I really need here. And this right here is going to be, in a sense, my endpoint, which is usually the translation moving 3 units to the right and 5 units up. So now if I do that, 3 units over, 5 units up, then 4 units over, 3 units down. So the graph is going to look something like that. Type of function, this is a square root. The endpoint is going to be 3, 5. And yet again, the endpoint is usually the c value and the d value of the function domain. So since 3 is going to be that first number, 3 to infinity, and why is it 3? Because if I end up actually putting in a number that is a little less than 3, this minus 3 will end up taking over, and so then the value underneath the radical would be negative, and we know that we can't have a negative value inside the radical. Since this range is going down, we would start off with negative infinity and go all the way up to 5, and since we are including that point at 5, it would be including it, so we're going to put a bracket. Increasing interval, there is no increasing because it is heading downwards. Since this is heading downwards, it is going to be decreasing. So we would say it's decreasing from, and remember, we do this from the x intervals. So when x is equal to 3, right, and then goes off to infinity. And we want to bracket 3 as well. Remember how I kind of talked about that in class? Some books end up saying that the value that you actually start on is not included in the decreasing or increasing interval, but you do want to actually include it for the terminology if you plan on going to advanced calculus and stuff like that. Okay, as x goes to negative infinity, it does not exist because, right, there is no values that as I'm heading in this direction, there's no x value, so we would say it does not exist. And then as x goes to positive infinity, this would be negative infinity. Okay, pretty straightforward. Okay, moving on to number 2. My parent function here, it is y is equal to x squared, and in this case, it's going to look like this. Smiley face. Okay, so I'm going to notice that there we have this minus 5 and then this plus 3. So minus 5 means I'm going over 5 units, up 3. So I end up having that vertex. Yet again, can always make a table for yourself. So this is 5, and this is 3 right here. So I would do 4 and 6. And if I do this kind of quickly, 6 minus 5 and then squared, that's 1 squared, which is 1 plus 3. So it would give me 4, and this would also give me 4. So we end up getting something that looks like this. 1, 2, 1, 2, 3, 4 also. And since there is no vertical stretch or horizontal shrink or horizontal stretch or vertical shrink, there's no different a or b value, right? This is going to just look like your normal parent function, except just moved over 5 units to the right, 3 units up. Type of function, quadratic. You can also say that it is a parabola, a parabola. My endpoint, there is technically no endpoint. We're going to call this the vertex, which is in a sense the bottom point right here. So we would call that 5, 3. The domain here is all real numbers, so we don't have any types of restrictions in terms of putting in the x values like we did with the square root function. The range, that's going to be from the y value, notice how it starts at 3 and goes to infinity. The increasing interval is going to be from 5 to infinity because at this specific section right here, it is going up. So we're taking the x value from 5 to infinity, and then it is decreasing from negative infinity until I get to 5. So we'd say negative infinity until we get to 5. And yet again, brackets on both of those points. Yet again, your teacher might end up changing that around a little bit. Some teachers will say parenthesis 5 to infinity. I'd say both are acceptable, but when we get into AP Calculus, it is important that we're also including the value that it goes to. Okay, as x goes to negative infinity, y goes to infinity, and same thing for as it goes to the right-hand side. Moving on to ln of x. So ln of x, right, always has, so y is equal to ln of x. We always have this point that is going to, in a sense, be 1 comma 0. Now, why is that so? Because if we think about how this is set up, right, ln of x is really just saying log base e of x is equal to y. And then we would do e to the y is equal to, in a sense, x. So sometimes it makes more sense to actually put in a y value and get an x value, right? It's that whole base to the answer equals the inside. So if I did e to the 0, that would give me 1. And so my y value is, in a sense, 0, 0 right there. And then my x value, which is now 1, is going to be 1 there. Now I could do other types of values right here. I could say e to the first is equal to, well, just e. So I would say the y value, if this is equal to 1, this is equal to e. Now, that makes it kind of confusing. A lot of people might not necessarily understand that, but we also have this understanding that ln of e is equal to 1. So if I place in e into x, that would also give me 1. Okay, if you're still kind of confused, just type this into your calculator and get your values from there. The minus 1 means that it's going to be moving over, in a sense, 1 unit to the right. Now with the parent function, we have a vertical asymptote at x is equal to 0, and we move the graph up to hug that asymptote, and then it kind of curves up like this. Now I'm going to move everything over 1 unit, so I'm now going to have my vertical asymptote at x is equal to 1, and now that point that was originally at 1, 0 is now going to be at 2, 0. And now, so I might end up having some other types of values that kind of help me along with this. So I can use Desmos to kind of help me along. I can also kind of think, if I wanted this value to be e, this would be 2.718. And the x value changed by 1 unit over. So really it would be 3.718. So 3.718. So like, let's say that that would be right there. And then moving up 1 unit. And then there's my curve. And then you can always get decimal versions from your calculator to kind of help you along with that. But really what this here is, this is really saying e plus 1, and then that's going to just be 1. And the plus 1, where does that plus 1 come from? That plus 1 comes from, in a sense, doing the opposite to get rid of that minus 1 that's already there. So I get ln of e, which is equal to just 1. Type of function, logarithmic. So you can also call this natural log as well. My endpoint, there is none, because the graph just keeps on going forever in either direction, right? Whether it be negative infinity or positive infinity for the y values in those types of locations. So domain, the domain is going to be from 1 to infinity. Notice how I'm putting a parenthesis around 1, means I'm not including that 1 value. Range is going to be all real numbers. Increasing is going to be from 1 to infinity. Now the reason why I'm not including 1 is because the 1 value does not exist, right? The vertical asymptote causes that issue that graph gets infinitely close to 1 but never actually touches it. There is no decreasing interval. As x goes to negative infinity, y or f of x does not go to infinity. It actually doesn't go to anything, so b does not exist. As x goes to positive infinity, y is also going to be going to positive infinity, because the graph is going up in a sense. If we take a look at this section right here, right, we can see the graph does gradually go up, but it does go eventually to infinity. And I'd probably say vertical asymptote is going to be x is equal to 1, even though it's not really listed here. Something that you just should know. Okay, moving on. Cube root. Cube root looks something like this. So I can see right here that this is going to be a reflection over the x-axis, and then we're going to be moving it 5 units down. So if I actually start at 5 units down, that'll be right there. That's also a way of thinking about this as saying x is equal to 0, so cube root of 0 is 0, 0 times negative 1 is 0, 0 minus 5, which is negative 5. Now if I end up choosing, let's say, negative 1 and 1, hence this is not vertically stretching or shrinking at all, I can think about this as negative cube root of negative 1 minus 5. And so this value right here, the cube root of negative 1 is negative 1, but there's also a negative in front. So it's really just saying 1 minus 5, which is going to give me negative 4. And then do that again for 1, so negative cube root of 1 minus 5. Cube root of 1 is just 1, negative 1, because of that negative right there. So negative 1 minus 5, which is going to give me negative 6. So negative 6, and this is negative 5. So this gives me a value right here, and really that's all I really need. And then I know that it curves up like this, terrible graph, and then right there. Okay, type of function, cubic, or cube root. No, cubic is something else. Endpoints, I would not say endpoints, I would call this the point of symmetry. So the point of symmetry is going to be 0, negative 5. It's not considered to be an endpoint because it's not on the end. Domain, all real numbers. Range, all real numbers. Yet again, since you guys have the ability to use a calculator, right, you can get the idea of what the graph actually looks like. Use second graph to get table values to help you along with trying to figure out how it looks. If you're having a difficult time plugging in the cube root of something, right, we want to press the math button and then look for, in a sense, there will be a square root function and then there will be a cube root function. But you could also think about it like this. You could say y is equal to negative, so put a negative, parentheses, x raised to the power of 1/3, because we know that the cube root is another way of saying x to the 1/3, and then type in minus 5. There's multiple ways of kind of saying that out. Increasing, it is not increasing, so we would say none. Decreasing, it's actually going to be decreasing the whole side because, right, we always look at a graph from left to right. And it's decreasing the whole way through, so we'd say all real numbers. As x goes to negative infinity, y goes to infinity. Right, as we're going in this direction, the graph is going up. As we're going in, x goes to positive infinity, right, the graph is going down, so we'd say negative infinity. Still doesn't look like a good infinity symbol. Okay. I think, oh, nope, I have some more for this page. Okay, this looks very, very confusing. What I'm going to do is I'm going to actually kind of adjust this a little bit. If I think about how 1 over 2 to the negative x, this is actually just equal to, if I take that negative out, it's really just saying I want to flip the fraction. So I'm really saying 2 to the x. So it does this kind of confusing thing, but what we're really saying here is this is actually equal to 4 times 2 to the x plus 1. Because as soon as you make it negative, it actually flips the whole fraction or whatever it may be. So if I had, like, let's say 2/3 to the negative x, I could rewrite that as 3 over 2 to the x. Now if I had, let's say, 2 to the, let's say I had 3 to the negative x, that could be equal to 1 over 3 to the x. Right, there's other types of versions that can kind of come into play, but really what you're doing is you're flipping that fraction. All right, so this is really the graph that I'm going to be graphing. Okay, so with these types of functions, right, we normally have a graph we normally have a point at 0, 1, and then the graph ends up looking something like this. Very similar to, I thought it was number 1. No, guess we don't have that. All right, so with this one, right, we have this point right here that is 1, 0. But since we have this vertical stretch, this number 1 is not going to be 1 anymore. It's actually going to turn to 4, and then the plus 1 is going to add 1, in a sense, to the y value. Now, that might be sort of difficult to kind of understand, so what should you always do? Make yourself a table. So I'm going to plug in x is equal to 0, x is equal to 1, and I can even do negative 1, so to speak. So if I do, in a sense, I don't have enough room. So 2 to the 0, that would end up giving me 1. And so what I'm doing here is I'm doing 1 times 4, and then plus 1. Okay, so 2 to 0 is equal to 1, 1 times 4, and then 4, and then going on from there. I don't want people to think that it's more than equal. So 1 times 4 plus 1, so it's going to give us 5. So we have the point 0, comma 5, so I'll be right there. Negative 1, so we're going to say 4 times 2 to the negative 1, which is another way of saying 4 times 1/2, which is another way of saying 4 divided by 2, which is 2 plus 1, so that's going to be 3. Nope, 3 for the other one. And if I said 1, that would be saying 4 times 2 to the first, so that would be 4 times 2, which is 8, plus 1, so that would be 9. Okay, so negative 1, comma 3, so that would be right there, and then 1, comma 9. Since this shifted up 1, normally we would have a horizontal asymptote at y is equal to 0. So now since it shifted up 1, we're going to now have a horizontal asymptote at y is equal to 1. And I know since the graph is going to be kind of hugging that, I can just start to draw my exponential graph like this. Type of function, exponential. Y-intercept. Looks like that's going to be 0, comma 5. Some math teachers will say that you can just include 5 and then just call it a day. You don't need an order pair, but it's always a good idea so that you have an understanding that it's really when the x value is equal to 0, y is equal to 5. Yeah, asymptotes. Oh, now this one has it. So we say HA, which is my horizontal asymptote, and I would say y is equal to 1, because everything was shifted up 1 because of that plus 1. Domain, all real numbers. Range, it is going to be from 1 to infinity. Increasing interval, all real numbers, because it's increasing throughout the whole graph. Decreasing, none. Is it 1 to 1? So that means is its inverse also an actual function? Now there are two ways of figuring out whether it is 1 to 1. That means that we would find the inverse to this and see if that inverse is a function. But there's also this method called the vertical line test and the horizontal line test. If it passes the vertical line test, mean that if I put in vertical lines and it only hits the graph once, then it means that that is a function. But we also have a test to determine whether it is going to be, if its inverse is going to be a function. And that is called the horizontal line test. So if I have horizontal lines coming in, right, do they only hit the graph once? If they hit the graph twice, then you know that its inverse is not going to be a function. The original can still be a function, but its inverse is not a function. Now, some of you guys might be thinking, well, in this section, it looks like that the graphs get really close, so that's almost going to be horizontal, but it is still technically going downwards. Even though it is getting closer and closer to some type of value, they will never actually have a horizontal line. It is always going down at a slight angle, ever so small. Okay, so is this 1 to 1? So does it pass the vertical line test and the horizontal line test? That it does. As x goes to negative infinity, y goes to, in a sense, 1, because that's the horizontal asymptote. As x goes to positive infinity, y goes to positive infinity. And is this exponential growth or decay? And really what we're doing here is we're trying to look for b to the x, whatever this b value is. If the b value is, in a sense, greater than 1, it is growth. If it is between 0 and 1, it is decay. And so they did this thing where they were trying to be kind of confusing and like almost like a haha gotcha thing, right? The b value here looks like that it is 1/2, but it also gives you a negative x. So what you want to do is you want to try and get rid of that negative x by flipping the fraction, or in a sense the b value, if I'm looking at this as y is equal to a b to the x plus d, right? This value, right, whatever the b value is, and then x has to be positive. So, is this exponential growth or decay? It is growth. And you can always just type this into your calculator and see how it actually looks. Right, moving on. All right, so 2 to the e x, or 2e to the x minus 1 plus 1. So this means I'm moving it to the right one. This one means I'm moving it up one. And this 2 right here means it is a vertical stretch. So this is actually the same deal, right? We still have a point that is normally at 0, 1 for y is equal to e to the x. And the graph looks like this. Okay, so we start off with the vertical stretch. So instead of it being 0, 1, it's now going to be at 0, 2. So it would normally be at here, I'm going to move it right 1 unit and then up 1 unit. So this is actually going to be my real point of where I start. Also, table, like I keep talking about before. So I want to make that 1. So e to the 0, in a sense, times 2 plus 1. So this gives me 1 times 2 plus 1. So that's going to give me 3. And that actually makes sense on why I'm at 3 right here. Okay, now to get the other values. This is where things start to get really, really kind of confusing, especially if you don't have a calculator. But if you have this understanding of how like this graph goes, really to tell you the truth, you only really need 1 point. But let's say that I want to try and figure out what 2 is. So 2 is really saying it is 2e to the first, or just 2e, right? Because 2 minus 1 gives you 1, and then plus 1. Now, some of you guys might be thinking like, okay, what does that look like? What is that estimation? And I'm going to actually just type that in my calculator. I'm going to type in 2e plus 1, and that ends up giving me 6.437. 6.437. It is up 1 unit, so I'm going to have a horizontal asymptote at y is equal to 1. At 2, I'm going to be at the 6, so a little bit before there, so like maybe there's a good estimation. So after 6, so 5 is right there. So 6, and then a little bit up from there. So like there. And I know it's going to hug this asymptote, so it's going to come up like that. Okay, type of function, exponential. Still, even though that the base is different. My y-intercept, now that's actually a really good question. So when that is equal to 0, that is going to be 2e to the 0 minus 1 plus 1. So 2, and then this is actually going to be e to the negative 1, but actually I can write that as 1 over e, and then plus 1. Now you can get your estimation in terms of whatever that value is, but if you really wanted to be fancy and exact, your y-intercept is going to be 0 for my x value because the x value is going to be equal to 0, and it would be 2 over e because this 2 is being multiplied by this 1, and it's over e, plus 1 is my actual y-intercept. And actually, to tell you the truth, that is the most accurate type of answer that you could have. Now, 2 divided by, now I'm going to actually type this in my calculator so that you guys have a number. So 2 over e and then plus 1 is going to give us really roughly, right, 0, 1.736. And right, that decimal goes on forever, does not stop, so that's why we refer to e as an irrational number. Asymptote, y is equal to 1, right, because y is equal to 1 here. Domain, all real numbers. Range, 1 to infinity. Increasing, all real numbers. Decreasing, I was just writing decreasing. This is none. As x goes to negative infinity, y goes to negative 1, because as we go in this direction, what is the y value that gets closer to? That would be 1. And then growth or decay, this is still going to be growth. Because even though e is my base, right, it is still between, well, it's not between anything, it is greater than 1 because 2.718 is definitely larger than 1 for my b value, or the base of the exponential function. Okay, so what am I sitting at in terms of time? I'm at 23 minutes. Great. I'm going to stop here and then probably pick up on the next page, and then we'll go from there. Thanks for watching.